Okay, our last unit, Unit 7, we're going to start by talking about composite functions. Okay, so I'll go ahead and read the definition and we'll kind of look at this diagram. So a composite function f of g is the composition of f and g is defined right here. So we're going to see this notation. And what this just basically means is that you're going to take the g function and plug it into the f function. So x is going to be the domain of the g function, and then your result is the domain of the f function. Okay? So what's going on here is you got your domain for g right here. You plug it in and you get your results. Okay? Then those results become the input, your domain of the f function right here. Now there is a way to go from, I like to call these like your little pools. Okay, these are mappings of like, just think of these as piles of numbers. Okay, so you go from this pile of numbers and then they pair up with pile, like this pile over here, and then end up into the third pile. Well, there is a way to design in a function that will just go directly to your third pile. And so we'll look at that in a little bit, but first we're going to start out kind of basic, and we're just going to start plugging in numbers and kind of seeing how this works. So this is not uncommon in real world situations to have for a function's input value to depend on the output of another function. So I have an example here. We're not going to have to do word problems, but this just kind of just gives you a little perspective of what's going on here. So the number of units of a product produced depends on the number of workers producing them. So this could be your number of workers, this pile right here, how many people are working, right? And so the more people that are working, the more, you know, of this product that's going to get produced, okay? So we can just put P for product, right? So you could get, you know, if you have a shortage of workers, you're going to have a shortage of the product, right? And so then, in turn, that's going to affect the cost, right? So then the cost. So the cost depends on, you know, supply and demand, right? So how much of the product is out there, okay? But then again, wait a second, that depends on how many workers you have that are working in the plant creating it, right? So anyways, that was just one example, but like I said, you're not going to have to actually do word problems here. We're just going to try to get a basic foundation of this. Okay, so starting here, what we're going to do is we've got these three functions, f of x, g of x, and h of x. So they want us to find the following. So once again, this is a notation issue, so we want to make sure you understand the notation. So what this is basically saying is f of g of -1. So what we're going to do here is you need to figure out what g of -1 is. So what we're going to do is plug that in here, and I'm just going to go ahead and leave it in this parentheses and do all the math. So I'm going to plug -1 in here and here. And so let's see, so I'm going to have -1 squared minus 2 times -1. Then I get a -6. Okay, then I'm going to close that. Let's see, so let's see, -1 squared, that turns into a +1. -2 times that -1, that'll become a +2. Then I have that -6 right there. So when I simplify all this, this should turn into f of -3. Okay, now I'm not done solving it though, because I just did the first part. I plugged in g of -1, figured out what that result would give me, and now it's time to take that result and plug it into the f function in this case. So that's going to give me 3 times -3. Then I have a +1. Okay, so 3 times -3 is -9, plus 1 is -8. And so that's my answer. So if you want to, you can pause it and try these others. If not, here we go. So this notation, this guy goes second, so it's going to go h, then parentheses f of, and then what am I plugging in? I'm plugging in 1. Okay, so that's what that notation is, okay? Make sure we know the notation, that's half the battle. So now we're going to substitute that in over here to figure out what we get. So now we're going to have h of, it's going to be 3 times 1 plus 1. So all I did was take my f function, plugged 1 in here, 3 times 1 plus 1. So So then now that's going to give me h of 3 plus 1. So now I have h of 4. Now the h function is x cubed. So that's just going to become 4 to the third power, which is 64. Okay. All right. So 5 is kind of similar to number 1, except they switch the order. Okay, so it's f of, g of f of 5. And they also changed the number, obviously, here. All right, so we're going to do here, let's see, so that's 3x plus 1. Okay, so we're going to have g of f of 5. Okay, now the f function was 3x plus 1. So this is going to turn into 3 times 5 plus 1. And so we'll go ahead and simplify this. So that should give me g of 15, oops. So that froze on me there for a second. Sorry about that. So let's see, 15 plus 1. So now we're going to have g of 16. So now I plug in 16 to the g function. So I believe, let's see, the g function was x squared. So it would be 16 squared. And then I believe it was minus 2 times x, which in this case would be 16. And then a minus 6. So let's just double check, make sure I got that right. There, okay, so yeah, x squared minus 2x minus 6, and so just need to do the algebra here and I'll be done with that one. So let's see, that's 256 minus 32 minus 6. So let's see, take off 32 from that. Let's see, that'll give us 224. 224, take away 6. Let's see, that'll finish up with 218. Alright, so that's what we get for number 5. Alright, so we're going to do one more with numbers, and then eventually we're actually going to leave it as a variable, and it can get a little interesting. Here we have g of g. Okay, so you're just going to plug it into the g function twice. So you're going to plug in g of negative 2, get that result, and then plug it back into the same function. Okay, so if I remember right, let's see right here, this is going to become, let's see, negative 2 squared minus 2 times negative 2, and then we have that constant on the end, that minus 6. So we're going to go ahead and clean this up a little bit here. So we're going to end up with g of 4. This will become a plus 4, and then let's see, that'll be a minus 6. And so if I clean that all up here, this actually turns into being g of positive 2. Okay, so all I did was plug in negative 2 to the g function, get my result. Now I plug it into the second function here, which just happens to be g again. So let's see, so we're going to have 2 squared minus 2 times 2, and we got that minus 6. Alright, 2 squared is 4, and then here you'll get a minus 4 and a minus 6. And I think we can see that basically, 4 minus 4 will give you 0. 0 minus 6 gives us negative 6. So now as we go to our next page, what we're going to do here, we're going to do the same thing, except now we're going to actually plug in expressions with variables. And so our answers aren't just going to boil down to a number, it's actually going to boil down to a function. And what that function is going to be is this right here. It's going to give us the shortcut to go all the way from pool 1 to our third pool over here. So we're going to skip the kind of stuff in between. But we're going to have to be a little careful because they are going to ask us for the domain, okay? So in order to find the domain, you got to kind of be careful because sometimes whenever you combine these functions together, some of the excluded values kind of get hidden. And so you have to be a little careful. So you got to figure out what your domain is in the first jump right here when you go from here to here. But then you're also going to have to figure out the domain on your second jump, okay? So basically, you're going to have to figure out the domain of the function you're plugging in, and then that new function that you get, basically, your answer. So the answer you get, you're going to have to look at both of those domains, okay? it's going to sound a little complicated, but it's really not that bad. The first couple are going to be kind of simple, and then we'll get to some that might be a little bit more challenging. So we'll go ahead and get started here. So they want us to find f of g of x and g of f of x, and then find the domain of each. Well, like I said, we're going to start out kind of easy. So this first one, the domain for both of these are actually, there's no limitations. If you were to graph these are both lines. Okay, so if you were to graph those, they're just lines. So there is no restriction in those domains. You can tell just by looking at the picture, but also there's no fractions, there's no radicals, so you really don't have to worry. So there's not going to be any restricted values for either one of these. So if you look at f, we'll start with f of g of x, and so this converts into f of g of x like this, written in this format. And so see, you're about to plug these values in right here for x, and so before you plug it in, you look at this, you're like, is there anything restricted? And we already talked about that. No. Okay, so now we'll go ahead and do that. So we're going to have f of x minus 3. So I'm going to take that x minus 3 and I'm plugging it in right here. So that's going to be x minus 3, and then I want to color code this. Then I still have that plus 3 on the back. Okay, that's where that's coming from. So that was part of the function. So I replaced the x with the x minus 3, but don't forget part of the f function was that plus 3 right there. Now what happens here is these actually just kind of cancel each other out, and your answer is just x. And now let's clarify. What your answer is f of g, the answer to this equation right here, f of g of x. So your answer just boiled down to x. That was kind of nice. And so there were no restricted values from the original function that got plugged in, and there is no restricted values in this new function. There's no fractions, there's no radicals, you don't have to worry about that. So the domain from this one's going to be from negative to positive infinity. Okay, so now we'll look at it the other way now. Now we'll go ahead and do g of f of x. And so what this, once again, notation's half the battle. What this is saying is take the f function, take all those results after x is plugged in, which is basically, that's this right here, right? You plug in x, and whatever x is, we leave it as a variable because then it really leaves open infinite possibilities. So we're going to take this expression, all these possibilities, and we're going to plug it into the g function now right here. Okay, so we're going to do g of, we're going to plug in the x plus 3 into the g function. And so you have the x plus 3, and then once again, I'll color code this to see this. Then you have that minus 3 right there. You have that minus 3. And so just like the previous problem, actually, those cancel out with each other, and you just get x. And so that's the answer to this right here. And so then once again, this one didn't have any domain issues. If you look at f of x, there was nothing, there wasn't any issues, and the final answer didn't have any issues. So kind of boring, not really any issues with that. Okay. So let's look at our next one. We're just going to keep doing the same thing. That's going to be the rest of this section right here. Like I said, we'll get into some that'll be a little bit more interesting. And so if we look at this next one, once again, there won't actually be any domain issues on this one, but we will have some on the next one. But if you look here, there's no restrictions on your domain for f or g. F, once again, is just a line, and if you look at g, that's a parabola, if you remember those. So there are not any restrictions. And so we'll go ahead and start out with f of g of x. So f of g of x. And so what we're going to do here is we're going to take this and replace g of x with that. So this is going to be f of 3x squared minus 2x minus 1. And so we're going to take that and substitute it right there. So this is going to be 3x squared minus 2x minus 1. And then don't forget, we do have that plus 1 on the back end. Okay? And so that minus and plus 1 will cancel out. And so you're just left with 3x squared minus 2x. which once again, that, you know, that doesn't have any restrictions. So your domain's going to be from negative to positive infinity. There you go. Okay. Now this other way is, y'all have the skill set for it, but you'll have to recall some of this stuff maybe. So let's see, g of of x, and so that's actually that's the same thing as g of fx right here. And so we're going to go ahead and this time we're going to place x plus 1 where we see these x's here. So it could get a little interesting, but we should have the skill set for that. So once again, I'll write in what we're going to plug in. We're going to plug in x plus 1. So when we do that, you're going to have 3 times x plus 1 squared, and minus 2 times x plus 1, and then that minus 1, the constant right there. So you can't just distribute the 3 yet. You can distribute the 2, and we will, because it has an understood power of 1, and so it's in, those numbers are both in, the same realm right there. Now here we have to go ahead and square this prior to distributing the 3. So we got a little bit of algebra we got to clean up here. So the trick I like to do is square the first one, multiply these together and double it, and then square the second part of it, which would be plus 1. I'll go ahead and distribute this 2 now, sure. So minus 2x minus 2, and then we don't want to forget the minus 1. Now, if you wanted to, you could have actually broken that apart and foiled it if you wanted to. You could have wrote it as, you could have done, x plus 1 times x plus 1 if you really wanted to and foiled it. You get the same result right here. Alright, so now I do need to distribute that 3 here. So let's see, it's going to give us 3x squared plus 6x plus 3 minus 2x minus 2 minus 1. Alright, so last but not least, let's combine our like terms. So we got our highest power right there, 3x squared. I don't see any other squares. Let's see, we got a plus 6x minus 2x. That should give us a plus 4x. And then our constants, let's see, we got a plus 3 minus 2 minus, okay, well, those actually are all going to cancel out. And that is my result. That's what this equals right here. And once again, my domain didn't have any restrictions, so we're not going to worry about that. Okay, so I just have a couple more, and we'll look at some that might have a couple more interesting situations. Okay, so here, so you can see that our domain is not all real on both of these. You can see that they have restricted values. You should hopefully recognize this from our rational functions from our last unit. Remember, you can't divide by 0. So if you were to take this and set this equal to 0 and solve, let's see, so we'd have negative, okay, is it freezing up on me? Let's see, there we go, okay, 5x equals negative 1, divided by negative 5, divided by negative 5, so we get x equals 1/5. Now that value is actually off limits, so part of my f of x, part of what's restricted from my domain is 1/5, because if I plug in 1/5, I'll end up dividing by 0. And so that's restricted. Now the g of x restricted value is a little bit easier to see. That's just going to be 0. 0 is restricted because you don't want to divide by 0. I'm going to go ahead and erase this just because I'm going to need that room working this problem. Okay. So we're tasked with, we'll start with f of g of x, f g of x. Okay, so right away, my domain right here, I got to restrict 0. So I already know, you might, if you want to, you can just make a little note that, okay, x can't equal 0 for this function right here, okay? And we might end up getting another value also that's restricted besides 0. So we'll see in a minute. Okay, so what I'm supposed to do here is I'm going to plug in 1 over x, and I need to plug it in right here for the f function. Okay, so let's go ahead and do that. So let's see, we're going to get 4 over 1 minus 5 times 1 over x. Okay. So let's see, that's going to turn into 4 over 1 minus 5 over x. So remember complex fractions? Hopefully you do. We don't like having fractions within a fraction, so we need to somehow fix this. And so one of the ways we did this was that basically what I'm going to do is multiply by like x over 1, x over 1. Basically multiplying by 1, but it's going to manipulate this in a way to kind of help me out here. So 4 times x over 1, that's just going to become 4x. And then on bottom, 1 times x over 1, that'll just become x. But then right here, this is going to become 5x over x. And so what that does is that's going to help me to where I'm going to simplify that fraction, so I won't have a fraction within a fraction. So hopefully I'll remember that. Let's see, so this should reduce to 4x over x minus 5. Okay, please do not try to cancel the x's out. Remember, it's all or nothing, okay? It's been a while, but try to remember that. So that's your actual result to this right here. Now we have to be careful because we did come up with another restricted value. Here, another restricted value would be that x cannot equal positive 5 either. So those are going to be restricted from your domain. Okay, so the way we're going to write our domain is it's going to be from 0. Oops, fix that. Well, maybe I can just write the infinity symbol. There we go. It's going to be from negative infinity to 0 union 0 to 5. Okay, then union from 5 to positive infinity. So we kind of had a little breaking between negative and positive infinity. We had a little breaking point at 0 and 5 because those values were restricted. So that's going to be that part right there. Okay, the good news is the next one that we have to do part 2 of this, basically where we're going to do g of f of x. This one actually will be a little bit easier to work with. So let's see, we'll write this. So it's g of f of x. So we got to be careful because you're about to plug in a function. You're about to plug in the g function. And so you got to realize, oh yeah, 1/5 is off limits. Because like I said, sometimes when you plug it in, that restricted value can kind of get hidden. Because, I mean, look at our answer. Our answer, you'd be like, wait a second, 0 is not excluded. This is from our previous one. You might be like, wait a second, 0 is not excluded, but there's some things that might be hidden in the arithmetic that we didn't, that we're not aware of when we get to our final answer. And so you gotta you gotta look for these things ahead of time. So looking at this function here, before I even get started, I do want to make a little note that x cannot equal 1/5. And maybe there'll be more, maybe there won't be more restricted values, so we're about to find out. So, so in the g function, I'm going to have to plug in 4 over 1 minus 5x. So I'm going to have to plug that in right here. So that's going to become 1 over 4 over 1 minus 5x. So I have 1 divided by this fraction right here. Well, we've got another little trick up our sleeves that we learned when we were dealing with this unit, dealing with complex fractions. In this case, we can actually do keep, change, flip. And so that'll make life pretty easy right here. So we're going to keep the top part, then we're going to change it to multiplication, and then we're going to flip the denominator. So it's going to be 1 minus 5x all over 4. And then 1 times, you know, anything, you're just going to get the same result in return. So 1 minus 5x all over 4. And so that's our function right here. So just to kind of review this stuff, so you have a pot of like X values, and then you have a pot right here that's going to be, in this particular example, this would be f of x for this example we're looking at here. And then the last pot is your g of x. And so what we did was we came up with a formula to go directly from here to your third pile. And that's what this equation is right here. That's what this is right here, okay? Now, you're dividing by 4, so you don't have any restricted values on this function, but 1/5 is off limits because it kind of got manipulated to where we don't realize that that's an excluded value. And so that's why we kind of have to look at that before we get started. So we are going to have 1/5 off limits. So your domain is going to be from negative infinity, okay, to 1/5, and then union 1/5 to positive infinity. So we just had one little hiccup here that we had to exclude. But other than that, we should be okay. So the good news is we got 2 left, and they're not going to be nearly as challenging as this one was as far as the algebra is concerned. So it's kind of the good news. So let's go ahead and tackle those, and that'll be it. So this looks like it could get messy, but actually it's really not that bad. If you look at this right here, it's aligned, so there's no restricted values, nothing's restricted. Same thing with g of x actually, because you're dividing by 3. So even though it's a fraction, it's it's okay for the top to equal 0. So -7's okay. It's not excluded. So actually nothing's excluded out of either one of these. So we're probably going to end up without anything too crazy here. So let's see. So we'll go ahead and do our f of g of x. So it's going to be f of g of x. So g of x is equal to this. So we're going to go ahead and plug that in. So f of x plus 7 all over 3. Okay. So we'll go ahead and plug that in right here. So this is going to equal 3 times x plus 7 divided by 3. And then we have that -7 right there. Well, this x plus 7 is getting multiplied and divided by 3. So those two things actually cancel each other out. And we're just left with x plus 7, and then forget your -7. Oh, well, plus 7 minus 7 cancel each other out. And so this whole thing boils down to just x. That's what this whole thing boils down to. And so your domain is going to be from negative to positive infinity. Okay, so let's look at the reverse of this. So let's go ahead and look going backwards. So g of f of x, okay? So this can be g f of x. And so we're going to take the f function this time and plug it into the g function, so the 3x minus 7. So that gets plugged into the g function right here. So it's going to be 3x minus 7. I'm going to color code this just to make sure we're good. So we have a plus 7 and then divided by 3. Okay, well if we start to try to simplify this, you'll see that the minus and plus 7 cancel out, so you're left with 3x over 3. And then the 3's cancel out, and you're just left with x. Oh, that's weird. So I wonder if it happens for one, it will happen for the other each time. And the answer actually is yes. Sorry if there was a little glitch there. This thing keeps kind of giving me trouble. But so yeah, what I was saying was that yeah, if f of g of x simplifies into x, then so is the reverse. Okay, and that'll actually be what we'll talk about in the next section. But anyways, for now we'll just leave it at this. And so once again, the domain is pretty clean. Nothing's wrong with it. So I have one left with a radical, but other than that, it's not going to be all that interesting. It's going to stay pretty simple, hopefully. So if you look at F, there's nothing restricted, you're okay. But on G, there are some restricted values. So if you look at G, your domain's going to have to be from 0 to infinity, right? Don't want to square root negative numbers. But other than that, doesn't look too bad. So we'll start out with F of G of x, which is f of g of x. So we're going to take the g of x function and plug it in right there. So we're going to do f of the square root of x. So instead of being 2x plus 1, now it's going to be 2 times the square root of x plus 1. And there you go. I mean, that's it. We're done with that one. The only thing is your domain, be careful. We could only plug in positive numbers, and your answer can only take positive numbers, and that's what your domain is. So your domain is from 0 to infinity. Alright, so now let's look at our last part on our last one. Maybe not. Okay, sorry about that. My pen died. I had to charge it real quick, so I better hurry up. So let's see, g of f of x, okay? So this time we're going to plug the f function into the g function. Right now, nothing's restricted. Our domain's wide open. But the problem is we're going to take 2x plus 1, so nothing's at issue right now, but the problem is now it's going to get plugged into a radical sign, and so we're going to have to make a call on our domain. So let's see, this is going to become 2x plus 1 inside the radical, so I'm replacing that to 2x plus 1. And so that is the function right there. That's fine, that's what this is. But if you remember, radicals, we only want to evaluate at non-negative values, and so what that translates to is that the radicand, the expression inside, needs to be greater than or equal to 0. It's okay if it equals 0, but it needs to be greater than or equal to 0. So that will exclude any negative possibilities. So we'll go ahead and subtract. Okay, I'm going to give myself some more room. Okay, and so then we get 2x is greater than or equal to -1, divide by 2, divide by 2. So we get x is greater than or equal to -1/2. Okay, so that's my domain, but now I need to convert it to interval notation. So values greater than or equal to -1/2. So -1/2 to infinity. So you might be like, wait a second, you said no negative numbers. Well, these negative numbers will actually get offset by the plus 1. Like when you plug it in, multiply by 2, and then you add 1, to where your radical, by the time you square root, your values will be greater than or equal to 0. Okay, so that's composite functions. So the next section, you need this skill a little bit to kind of grasp our next section. And so anyways, alrighty then.